Hello, class. This is section 8.4, which is the final section of the class, and it's on mathematics of finance. So the first problem says, find the amount of an annuity that consists of 30 annual payments of $800, each into an account that pays 6% interest per year. So whenever they ask for the amount of an annuity, this is a formula that we're going to use. The F stands for final amount, R stands for regular payments, and I is the interest divided by the number of times that interest is compounded per year, and N is the total number of payments. So let's plug in all these values. It says that we're going to be paying $800 into the account, so that would be R. So R is $800. All right, I is the interest, which is 6%, 0.06. However, you need to remember to divide by the number of times that interest is compounded per year. And in this case, it looks like it's compounded per year. So sometimes it'll say compounded or interest semi-annually or quarterly or monthly. In this case, it's per year, which means divided by 1, just once a year. All right, and then the final thing we need is N, and N is a number of total payments. It tells you here that we're going to be making 30 annual payments. So that would be 30. So there we go. All we got to do is plug in these numbers, and we should get our answer to be, I'm going to type it into the calculator this way. I'm going to basically put the R in the numerator. 1 plus 0.06 divided by 1. You don't really need the 1 to the nth power, which is 30, minus 1, close bracket, all over 0.06. So if you type it in exactly the way you see it into your calculator, you should get the right answer. Let's see if we get it. 800, parentheses, double parentheses, 1 plus 0.06, close parentheses, raised to the 30th, minus 1, close bracket, divided by 0.06 is equal to getting 63,246.548, which rounds up to 55. See if we got that right. And we did. Okay, great. So that is our answer. The next one says how much money should be invested every quarter at 7% per year, compounded quarterly, in order to have $9,000 in 7 years. So this time we're looking for the size of the regular payments that we need to make per quarter in order to get this final amount. So this time we're looking for R. So A sub F, the final amount that we want is $9,000. Let's see, I in this case would be the interest divided by 0.07 divided by the number of times we're compounded per year. We're compounding quarterly, which means that means 4 times per year, so divided by 4. All right, and then N is the number of payments we're going to be making. Well, it looks like we're going to make payments for 7 years. 7 years and 4 times each year, so 7 times 4 is 28. So once again, 7 years, and we're making 4 payments per year, so 7 times 4 is 28. So that should do it. Let's plug in the values. 9,000 times 0.07 over 4 divided by, you're going to want to put a bracket here. 1 plus I to the, 1 plus I, which is 0.07 over 4, to the 28th power minus 1, close bracket. So type it in exactly the way you see it into your calculator, and that should do it. 9,000, parentheses, 0.07 divided by 4, close parentheses, divided by, bracket, parentheses, 1 plus 0.07 divided by 4, close parentheses, raised to the 28th power, minus 1, close bracket, is equal to getting 251.83, which is the correct answer. All right, moving on. All right, this time they're asking what is the present value of an annuity that consists of 22 semi-annual payments of $9,000 at an interest rate of 8% per year, compounded semi-annually. All right, so there's a lot going on here. So present value of an annuity, that's a different formula, and you can see the subscript is now P for present value instead of F for final amount. So let's see, we want our regular payments to be $9,000, which is a lot of money. R is 9,000, and our interest is I equals 0.08% divided by the number of times we're compounding per year, which is semi-annually. That means 2, so divided by 2. And then the number of payments that we're going to be making, it tells you that we're going to make 22 semi-annual payments. So basically 22 total payments. So that would be 22. So plugging in all these values, we should get 9,000. Once again, I'm going to put that in the numerator. I'm going to write it this way. Bracket 1 minus parentheses 1 plus 0.08 over 2 to the negative 22 power, close bracket, all of that divided by parentheses 0.08 over 2, close parentheses. So let's type that in. Okay, I am getting 130,060 and 0.038, which is 4 cents if you round to the nearest cent. And there it is. It is the same answer. Okay, moving right along. All right, a woman wants to borrow $13,500 in order to buy a car. She wants to repay the loan by monthly installments for 8 years. If the interest rate on this loan is 12.5%, wow, that's really high. Compounded monthly, what is the amount of each payment? Okay, so for this, we're looking for the amount of the regular payments per month, which is R. That's what we're looking for. And we know how much the car cost, we know what the interest is, and we know the number of payments. So we should have all the information we need. So the amount of the car is $13,500. The interest is 0.125, 12.5, divided by compounded monthly, which means 12 times per year. And the number of payments is going to be 8 years times 12. So 8 times 12 is 96. 96. All right, so if we plug in all these values, we should end up with parentheses 0.125 over 12 times 13,500, bracket 1 minus parentheses 1 plus 0.125 over 12, close parentheses to the negative 96, close bracket. All right, let's type that in just the way you see it. I am getting 223.138, which would be 14 cents if you round it to the nearest cent. And there it is. So that's how much she would have to pay per month for 8 years in order to pay off that car. That's a really high interest rate. I wouldn't buy that car at that interest rate. All right, last page. Here we go. What is the monthly payment on a 30-year mortgage of $200,000? Well, if that's a house, that's really low. They obviously don't live in California. At 12%, 12% interest per year, compounded monthly. Let's round to the nearest cent. So here's the formula. Once again, it's the same formula because we are looking for monthly payments or regular payments. It doesn't matter if it's monthly but in this case, it's monthly. We have the price of the house. We know the interest rate. and we know the number of payments, so let's write that all out. All right, the price of the house is $200,000. The interest is 0.12 divided by compounded monthly, that's 12. And the number of payments, well, it's a 30-year mortgage, so 30 times 12, since there's 12 payments every year, will be 360 payments total. So let's plug these values in. R will be once again, put that bracket there. Don't forget that negative 360 at the top, close bracket, and there we go. Let's see what we get. All right, I am getting monthly payments of $2,057 and 0.225, which would be 23 cents. Okay, now they're asking the follow-up question is, what is the total amount paid on this loan over 3 of the 30-year period? So you're not just paying this amount. That would be great if that was all you're paying. You're paying a lot of interest. So the question is, how much total at the end of the loan is going to be paid for, including interest? Basically, the price of the house plus all the interest, what is that total amount is what they're asking. So it just comes down to multiplying this amount times 360, because you're making this payment 360 times. So if you multiply those two numbers, you're going to get the amount paid on the loan over a 30-year period. However, you have to be super careful. Don't use this number because we rounded. You want to use the number that's already in your calculator. So the number that's in my calculator would be 2057.225194. So you don't want to round until the very end. We got one more step to go. We need to multiply that by 360 because that's how many payments they're making. So times 360, I'm getting 740,601.069, which would be 7 cents. All right. And look at that. The house is worth $200,000, and this is how much they ended up paying. So that goes to show how much interest they really paid. They paid a whole lot in interest. If you subtract these two numbers, you'll get the amount of interest they paid. That's a lot of money in interest. And that's because that interest rate is super high. All right, that concludes this section, and that concludes the whole semester. I hope you guys have a wonderful semester. It was a pleasure, and good luck to everybody in their future.